I want to just create like a Linux instance real quickly called Linux practice. Practice dash server. And I'll just choose that one. And I'll just click on create. Select my key, just Linux practice key. And launch instance. So while it's launching, let's continue with our let's continue with our class, right? We were doing where did we end last class? You guys know? I don't know where we ended.
I think system reliability.
We'll talk about users already, right? With
Yes.
our users, how different teams are structured for an application. We talked about this, SRE, talked about application support. So you'd be in one of these teams, right? Or even all of them, but you might do application support, environmental support, or one of this, right? This we'll talk about in more detail as well. Change management. Talk about the role of an SRE in production environment. Now, when someone say production environment, why is it production environment? I want to explain how companies develop software. So I'm going to teach the software development lifecycle, SDLC. So it's a very important thing that you must understand. I'll give you guys a diagram after class, but I'm going to teach SDLC, software development lifecycle. So you should understand how software is built, because if you're supporting software, you should understand how it was built, right? Same like mechanics who fix cars understand how a car was built, right? So software development life cycle. So you see how you have your AWS account, right? In a company, for one application, that application will have 4 accounts, minimum 4 accounts. Sometimes it's 5. Let's say the application is called Priceline, for example. Let's just say the application is www.priceline.com. It's a web application, right? The web application is Priceline.com. Web application, right? And this application has how many layers? It has what? This application has a web app and database layer. Right? It has these 3 layers. So in the beginning of the software development process, a developer, where is that? So UML, VPN. These are just shapes that architects use, right? So sticky notes, then value streams, there you go. You select the shapes. So the more shapes here I can use. So this is a developer, right? This is a development account. AWS account. Okay? A separate AWS account. Here, you have a test AWS account. Here, you have a stage AWS account. And then here, you have a production AWS account. So when a developer develops software, a developer is developing software. Developer. They'll develop the software in this account. They connect to this account to develop the software. Okay? They develop their software in this account. Okay? So they'll create an EC2 instance here, install Java, whatever, build the application. And then when they're done with the application, let me use a soft line here. When they're done building the application, you need to test the application. They will now move it to the test account. Now the question is, how did they move it to the test account? How did they move it to this account? There's a code repository. Code repository. A code repository is just simply a place where code is stored. Like where code is stored, like actual code, right? GitHub is the #1 code repository in the world. Build and ship software on a single collaborative platform. So they store the code here. All the developers will store their code in this platform called GitHub. Every company has GitHub or some kind of code repository where they store their code. Okay? So when a software builds the code, they store it in here. They store it in GitHub. Store in GitHub. And then now that it's stored in GitHub, they need to now test the code, right? You've built it. You need to now test the code. Now, another person a tester will connect to this account here to test the code. So the code is going to be copied from here into this box. The tester will test the code in here. Or to make it very simple, very, very simple, right? This developer push the code to this account. He stores it in here and then also push it to this account. How does it push it? Copy. What Isabel was trying to do, that copy command, you copy from one directory in a Linux file in here to a different directory in a different Linux server in this different account. I'll show you how to do it, right? It's called secure copy. Where is that the Linux file? Open recent files, Linux command cheat sheet. Open. Where is it? Oh, it's here now. Open Linux command cheat sheet. Right. Where is it? This is it. Linux secure copy. Copying from one server to another server. I cannot. Where is it? I had the Linux command sheet open up. Right, but it's called secure copy. SCP server 1 to server 2. Right? An SCP like that. Secure copy protocol. From one server to another server, you can do a copy like this. So you can SCP username at the server, the path, the source file, and then username at server to the path of the second file. You can copy across servers. So for simplicity, there's a developer copy the file over SCP protocol to this test account. So you have an EC2 instance here called dev in dev account, and now you copy the code over to the test account. The tester will connect to the EC2 instance, test the application, test it, make sure it's working well. When it's working well now, they now store the code here in GitHub repository. And they also now push the code here to the staging account. The staging account is like the final preparation before we go live. We've been building an application called Lift or price information for 6 months. Before we go live and everything starts going live and we'll start using the application, we're going to stage it first. Staging is the closest thing to production environments. Here, we're using a small EC2 instance. We're using like a T2 medium. T2 medium instance, T2 medium, which is like two CPUs, two virtual CPUs, and it's like what, 4 gigs of memory, something like that. Memory. Here we use a little larger, a T2 large, T2.large EC2 instance type, which is like a 4 CPU, 4 virtual CPUs, and I think 8 gigs of memory, something like that. Don't quote me on it, right? I don't cram, you're not supposed to cram these things. And then now in stage, since we're estimating that we're going to have 2 million users, we need to make sure that the server we use can handle 2 million users. So in stage, we're really going to stage the application with, you know, some real type of users, right? Some real capacity or real compute, so to speak, right? Real compute, so to speak. In that sense, then we're going to go ahead now and push the code here. And then once we push the code here, we will stage it. Here, we're doing user acceptance testing, okay? We're doing user acceptance. What is this? Here. The users that connect here are users, user acceptance. So we'll capture a few number of users that will be using the price.com application. They will connect to this account, right? And test the application out. Here, we're just technical testers, testing for the API response, testing latency, and you can be part of that as well, right? One person can do everything. One person can develop, test, stage, and deploy. That's called a DevOps engineer. DevOps engineer develop, test, deploy, monitor everything. But you may not be involved in development. You can maybe involved in testing. That's if only if you want to. It's not really your role. You can be involved only in testing and deployment. Okay, so user acceptance testing, you can come here and test it. Oh, okay, the response is fast. All those things. Then once is done well, so here they're using like a real type of instance, C5, maybe 4x large, which is like a 32, I think it's like no 16 V CPUs and like a 64 gigs of memory. Now, when they're done testing, they store the code in GitHub. Okay. Now, it's in GitHub. When it's now stored in GitHub now when you go to production, guess what? They now have to create something called a release. They have to release the application. Release. Releases are not done every day. Releases are only done once every 2 weeks or once a month or once every 3 months. Most banks do release like once every month. They don't do it every day because releases mean that you're going to change production. You're going to go change the live application that people are using live. It's a big deal. If it goes down, you guys have to fix it before it go back up. So that code that is in GitHub that's been perfectly stored, they'll create something called a pull request. They'll create something called a pull request. A pull request is just having a senior people to review it. This pull request has to be reviewed. Reviewed by a senior engineer or a manager. He has to review it. Once he reviews it and he approves it, once they review and approve it, once they approve it, then that's when it can now be released into production. Not deployed, released. That means the code will be copied into the production account. You copy. Once it's copied into the production account, now you can now log into this production account and deploy the application. Deploy the app. And it goes live. When you deploy the app, it goes live. That's when people can now go to www.priceline.com and they'll now be able to see everything. And this deployment of the app, that's where you have your 3 layers. You have the web layer, right? All your EC2 instances in there. You have the web. You have the database. You have the app layer. And you have the database layer. But before you even get to this stage where you have these 3 layers, the software has gone through this development. It tested, push the code in here, push it to stage, test it. It's good, they save it here. Then create a review now, approval. Then it's approved versus released to production. Then it's deployed, and then everyone uses it now. This whole process can take 3 months to 6 months or 1 year, depending on the application. If the software develops it and want to test it, it doesn't work well, guess what? They go back to development. And then they test it again, they push it here, they test it, it's working well, they save the code, push it to stage, test it. If it doesn't work well, guess what? They go back to development. That's why software takes time to release. They develop it again, it's working well, the test is working well, they push it to stage, it's working well. If it doesn't work well, back to development. If it goes to production, it's released, go to production, and it's not working well, if it's a quick fix, if it's a very quick fix, there's a special type of account. If it's a quick fix, like what's a quick fix? Less than 1 week, less than 2 weeks, we'll take it to an account called sandbox account. Sandbox means like sand in the ocean. You can just wipe it. So sandbox is a kind of where we'll just take things and then we can just wipe it real quickly. So we'll take the code that we push it here, take that code, bring in this sandbox account, change it, make the changes, push the code back, push it to a release, get it approved, deploy it again, and then it goes live again. And then when we deploy it now, we're not calling it, we're going to call it priceline.com/v2, version 2. That's what sometimes when you look in your browser, you always see like /v2, v1, things like that. That's the software development lifecycle process. So if you click on flights, for example, you might see like v2 or v1 or v3 because the application has gone through many deployments. Now we want to add a new feature for the application now. They develop the feature. Let's say we want to add cruise ships, or no, we want to add boat rentals on this app. We want to add the tab for boat rentals here. The developers will go develop that feature, push it to development, right? Then push it to test the feature. A tester will come and test the feature, click on boats, see how it works. If it's working well, everything is good. They push it to stage. Users who buy flights to come and test it, they'll release to some free users, real users, people who have a Priceline.com account. They'll send you an email that, hey, we're having a release a new feature. Can you test it out? You test it out. If it's good, everything is good, you give your feedback. Store the code in GitHub repository. Then when they want to go now, they will now schedule it. Releases are scheduled. We're going to schedule it for November 28th at 3 p.m. on Thursday. It's a huge event. They'll schedule it, invite everybody. Everybody will be informed the company. On Tuesday, November 28th at 3 p.m., we'll be doing the release and going live. They schedule it. Everyone is aware. The code is stored here. They do the pull requests. If you by a senior engineer, he approves it. He waits. The manager reviews. The manager approves it. When I approve it now, then I release the code now. The code is not pulled from the GitHub into the account. Not deployed, just pulled. Release is different from deployment. Release means that it has been approved for deployment, but not deployed. Now, it's in production. Now, on that day, November 28th, 3 p.m., we check, okay, it's not approved. Boom, we'll go deploy. Well, deploy now. As soon as we deploy, guess what we'll do? We'll start monitoring. Immediately we deploy, we'll start monitoring, looking at Prometheus, seeing the HTTP response, seeing how it's behaving, making sure it's stable. Users start connecting, you start buying things, buying like it's stable. 7 days is stable, we consider it. Once after 7 days of stability, we consider Priceline.com version 2. We'll give it a nickname, a stable release. That is a stable release, version 2. If something happens after a month, we go back and fix it. We'll go back to production, development, sorry. We take the code from here, right? Copy back to GitHub. Then pull this code from GitHub into development account, fix the issue, fix it, push it to test it, push it to here, test it, push it in GitHub, store it, create a release, create a pull request, managers approve it, or you fix it, you approve it, we release it. When we release it in production, deploy, it now becomes version 3. That's it. That's how software is developed. That's why whenever you're downloading software, all these things, you have to always check the version. That's what they say, version 1, version 2, version 3, version 4, version 5. Okay? Any questions on the software development lifecycle? It's very easy, right? You have to just know these 4 accounts: dev, test, stage, and production account. This staging account also has a different name as well. It has a name called UAT. It has a name called UAT. You see it on your resumes, guys. That's why I had to teach this. UAT means user acceptance testing. User acceptance testing. Okay. So you may not be involved with the development of the software, but you will be involved in supporting it. So it's important for you to just know that this is the process. So when an application goes down, something is very severe, they may have to go back to the beginning to start developing the application. So you're aware of the whole process and why it can take 6 months to get an update on that application. It might take up to 6 months, right? If it goes bad, it goes back, it comes back to development. Okay. Any questions?
Do we have this in our notes, right?
No, this is brand new. I'm teaching. It's not in your notes.
Oh, okay.
I'll give you guys his notes. I can give you notes about it. The issue is not the notes, Kobe. I'm sorry. Let me pause recording. I've given you guys so many notes. The issue. So software development cycle, these are the notes. I can put it, let me download and I'll put it in the chat right now. Software development lifecycle. This is very, very detailed, by the way. There might be so much information in here. That's why I'm saying that. Just imagine you went to the university, they gave you this, this is one class, or they take the whole semester to teach you just this thing. And I just taught you guys within 30 minutes. You know what I mean? And you went and paid $100,000 in college. Like, come on, man. What are we doing? I wish, come on now. That's what I says college is a scam. I went to college, but I shouldn't have gone. It's better you learn on YouTube, get a job, and then if you want to go to college just for fun, you pay for it out of your pocket. Okay, that's the note I've sent to you. There's more. You can Google it. There's more. There's more notes. You can Google, this another one, software engineering, software development life cycle. It tends to produce high quality software. It tells you what it is. It's many, many notes, agile, different things. It gives you history, telling you about, it was created in 1985. It's just a waste of time. It's a waste of time. You just need to know that in Cloud SRE, in AWS, When we build software, it goes from development database account to a test account, to a staging account, and to a production account. And the way it goes to production account, because production account is the main account, it has to go to a release. The release lifecycle process is to create a pull request. A senior engineer, a manager has to approve it. Once it's approved, then it's released into production environment, which means the code is being copied into production environment and the code is deployed. And then when it's deployed, the application is deployed. The application is deployed on a huge instance. Like it's deployed on it can be deployed on 6C, 5, 8x large clusters, 8x large EC2 instances. Because it needs to serve 2 million customers. And this 6 might have those two. If one instance has 64 or 32 CPUs and 64 gigs of RAM, of memory, as a RAM, that means that this application can take 6 times 32, 6 and 64. That's the total capacity compute for this that can handle 2 million users. And give these 2 million users what? 10 millisecond latency. That's the goal, right? Latency. Very, very low latency and high network throughput. Right? Users want to click on an application like this and it opens up very fast. That's 10 millisecond latency right there. Click on cars, boom. Click on airport, DFW, boom. Find your car, boom. It comes up really, really fast. That's HTTP response, really, really fast. Find your car, boom. That's it. Right? Searching, boom. Look at the response time, very, very fast. Right? That's the goal. That's the reason why we put so much compute, CPU and memory behind an application like pricing.com, because millions of users are going to use it and want it to be very fast. So this is a software development lifecycle. I'm going to take this image and send it to you guys. Export image, PDF, crop content. I'm going to send this to you in the chat. Do you guys get the documents I sent over the chat? Are you able to get it? Yes?
Oh, yes.
Okay, cool. So that's that with software development. It's something that you need to know, not that you're going to be involved in the whole process, but you just need to understand the process, because some of you as cloud SREs, you may have to be involved in the release process. You're not developing, but you're involved in the release process. Okay? So you're not doing the development, but you're involved in the release process. Okay? Any questions? Okay, cool. So let's check on our EC2. Let's do that really easy copy, right? That Isabel was struggling with. Where is it? That's my EC2 instance. I'm gonna connect to it real quick. Instance connect. Okay, Isabel, you say you created a directory, right? Let's just create a directory, source as a source directory, right? Source dash directory. Do ls-ltr, it's there. Create another directory, mkdir, target dash directory. ls-ltr. Come on now, why is it frozen? So ls-ltr. We'll have to that. So I want to go into source directory, see directory, and I'm going to create a file. vi, I'm going to do a sudo vi Prometheus dot YAML. I'm gonna hit I to insert. I'm gonna type some stuff in here. This is my Prometheus file. This is the config file. Just a test. To save this file, I'm gonna hit escape on my keyboard. Column WQ exclamation mark. That's it. We're doing ls-ltr. That's the file. Where is the file located? In the source directory. Okay, I'm gonna go back one step. I'm back in my home directory. This is the home directory. Whenever you see home plus EC2, that's home directory. To go to your home directory, you can just type CD and it takes you home. That's your home directory. Now, if you see it in the target directory on ls, it's empty. Total, there's nothing in there. So I can just go back home. And now I want to copy from source directory to target directory. So what I'll do is I'll do CP. I want to copy, now move the file. Just do a copy. Right? I want to just do a copy. But first of all, I'll do this so I can have this right here. So I do copy CP, copy this. And then it's slash source directory. And I'll explain why I'm doing this particular step. There's another method of doing this. That's easy. Directory. I'm copying it to the target directory, which is also under here. Target slash directory. Right? So I'm CP this. But under here, what file am I copying? I have to put a file name here. Right? The file name is Prometheus. If you hit tab, it completes it. Copy it from there to this location. You must put a forward slash at the end here because it's a directory. This forward slash is very important, even here as well, right? But here you have a file. So if you have a specific file that you want to rename if you want to rename the file, you can put the name here. And that's it. Copy Prometheus file from this location to location. I'm putting the full part of the location because I'm in my home folder. If I want to just put Prometheus or YAML, I have to be in the source.directory folder. But I have to always put this path because this part is a target path that I'm not there. Okay, so enter, and that's it. I've copied it. So now I'm here. I can now cd into target directory. And that's the file in target directory. That's it. Simple as that, copying the file. Any questions?
Okay, Dipo, if I'm in this directory, target directory, and I want to go to another directory straight to maybe let's say source directory, can I use the cd command or
That's a good question.
I have to go back home
Let's
first?
see.
The home instance.
Let's see. You're here. You're in target directory. What directory do you want to go back to? Source directory, right? Source directory is where? Source directory is under home / EC2-user, right? So you can just do this cd / source. And you're there.
Thank you.
Right? Because cd takes you one back to EC2-user, then / source directory. So you're going one back and then one forward. Now you're in source directory. Look at where you are. You want to go to target, just do what? cd / target. And you're back there. It's an advanced command. It's advanced things. So the reason why I had to copy, if I do history, I had to copy the full path is I'll give you guys an assignment about relative path and absolute path. So what is the difference between absolute path and relative path? I gave this an assignment about 2 months ago. One is the absolute path and one is the relative path. When doing copy commands like this, sometimes you have to do the full path, the absolute path, because you don't know, you don't have you're not currently in the location where the files are being stored. So you have to do the absolute path. Any questions? Any questions, guys? Come on, come on, come on. Ask, guys. Ask, but forever hold your peace. Okay. So no questions, then we'll continue with so that's that, right? So that's very easy, right? So it's just practicing, guys. So production environment is what we are going to be monitoring and supporting, guys. Full time, full swing. Production environment is what we're going to be supporting and maintaining full swing, right? So let's continue. So the role of an SRE in production environment, we talked about, system reliability, integrity, all these things, right? We'll talk about it last class already. It's your responsibility to monitor the health of the application, the health of the instances. Change management is what we just talked about, right? When you want to make a change, when you want to make changes to the application, we want to add a new feature to that, that's a change. So this process of doing the release is the change management process. Okay. It's a change management process. So let's go here. We talk about system reliability requires online system providing service to customers, needs to be monitored and ensured product developed for customers working as expected. Detected issues should be reported immediately, right? When you detect issues, you don't only have to solve them. You need to report them immediately. You don't have to solve them. You don't have to solve the problem, guys. The first thing when you see an issue is to report it. Send a mass email. Hey guys, we're experiencing latency issues in server number. This. I'm looking into it. Then you can start up a meeting, a Zoom meeting. People will join you in a meeting and start troubleshooting the issue. You don't have to do it alone. Your issue is like you're like a security guard. You see something and you call the police. That's your job. Your job is not to fix it. How do you know something is not working? There's two options. You can either be watching the dashboard daily, or you can set up the automation alerts and get an email. What you guys do will permit you to setting up alerts, right? To get alerts automatically. You don't have to be watching the dashboard daily. The vertical monitor, you have security. You have to monitor security. You have to monitor application health. You have to monitor system health. System health involves what? CPU, memory, storage, right? Application functionality. When users click on this function, is it working? And then databases. So these are the 5 most important things to monitor. These 5 things here. Application health is the HTTPS, all that stuff, right? So how do we monitor them? What are KPIs? KPIs are key performance indicators. Key performance indicators, right? Key performance indicators are the things that will let us know what's happening to the application, right? What we measure. What are the metrics that we're going to be measuring, that we're going to be looking into? Okay. So you have accounts and credentials. Accounts and credentials is one thing they're going to be measuring and looking into. So when people log in with their username and password, you're seeing if they're using any kind of easy password or it's just open like that, right? And then you have infrastructure access, right? How they access their accounts, password security. You have phishing attack pattern. Some people will send an email to look like it's coming from Priceline.com, but when it's not Priceline.com, it's some kind of phishing attack. But I'm monitoring for this kind of things. Access from an unusual location. When you see users logging in from, remote areas, India, Syria, North Korea, right? We know that it's probably a scammer, right? Because it's a US application. So when you see a remote user from an unknown authorization, unauthorized deployment, let me talk about that one. That one happens a lot. People go and deploy the application without getting approval from the manager or the senior manager. Do not attempt that. Please do not attempt that. It's it's frowned upon. People just go and, because it worked in stage account or UAT account, they go just deploy it in production without getting approval from the manager. That's unauthorized. It's unauthorized. Okay. And then you have patterns of API access incidents. So these are all application code issues. Intrusion attempts, people trying to attempt the application without access. They don't have access to it. So how to monitor? You have SPI, sensitive personal information. So bank account information, credit cards, CVV codes, all those things, we monitor them. Okay. Failed login attempts. When users fail to log in, we capture those things. How many times the user failed to log in? Maybe the user is not the one trying to log in. Maybe someone trying to access the account. So we have to send them an email saying, hey, someone trying to access your account. Is it you? Someone trying to access your account from IP address number this in Douala, Cameroon. Is it you? Right? Because if you're failing to log in many times, it means there's something wrong. Right? Geolocation mapping from IP. So geolocation mapping is tracking that person's IP address or geolocation from that IP address. We can extrapolate that. Error codes, vulnerability scanning. So we're going to be scanning the systems constantly for vulnerabilities. Vulnerabilities are pretty much like viruses that people send to your systems. Every single day, Google.com receives about 1 million viruses to its systems every single day. We want to just harm Google.com. Who knows whether it's Microsoft doing like a little Cold War between the two of them, right? Because people don't use Microsoft Bing. Microsoft Bing is like Google, but people don't use Microsoft Bing. People use mostly Google. So every day they receive 1 million, phishing attacks. So they're always scanning their systems for those kind of attacks. They have antivirus updates. They have the latest patch installation. What's a patch? What an operating system patch? An operating system patch is a software update for the operating system. Operating system patch. An operating system update. So operating system software update. Software update for, it's an operating system software update for security of the server. You need to always update the server security, because if you don't update the server security using this patch, people will be able to hack into that server very easily and steal information. Okay. Any questions, guys, so far? Any questions? Latest patch is very important. Every month, we have to patch the instance. So after class today, guys, I'll give you guys a list of tools and the URLs to go and create accounts with these URLs, and we'll start practicing monitoring. You have something called quick starts. For example, if you go to Splunk, you do a Splunk quick start like that. Splunk tutorial. Let's see, Splunk tutorial. Tutorial like that, something like that, right? And then you can choose Splunk tutorial in AWS. So you can go do this tutorial in AWS, right? Monitor your AWS environment in Splunk or the cloud. You click here, accept all. And it'll tell you how to do this tutorial. Connect with your AWS services, monitor and use them in Splunk or the cloud. Play with it, learn it. That's one tool. Splunk is a big tool. You can just learn Splunk and boom, you leave here and go get a Splunk SRE engineer job. That's it. SRE Liability Engineer Splunk. They're here in Plano and Dallas are hiring actually right now. Yes, in Texas. That's it. That's the salary. 146, 201 per year. San Francisco, Seattle, New York, right? Or remotely. That's it. They have 20 modules. Splunk is a big tool. Big tool. Most companies use Splunk. Okay. So just learn Splunk and then we'll learn many too, but let's start with Splunk. You see they're asking for it here. The engineer should be familiar with the monitoring tools such as Splunk, App Dynamics, Dynatrace, CloudWatch. If you look at my notes here, you have Splunk, Nagios, you have other tools that we want to learn. But I want you to start with Splunk. Splunk is the biggest one. App Dynamics, we want to learn CloudWatch, Grafana, Azure Monitor. Let's start with Splunk, okay? So that's your project for the weekend. Tutorial monitor AWS environment in Splunk Observability Cloud. You can connect to AWS, look at all the supported services. I will just say you guys go through all these steps right here like this. Read together, learn together, read everything. And then at the end, you just do the tutorial, right? You click next, connect to your AWS services. It shows you the screenshot here, how to connect to it, what to do, the steps, create a role, built-in services, everything. You click next. You add your IAM roles. You see a dashboard like this. You guys connect an EC2 instance. Everything is there, step by step. On the job, when you go to a job, they will ask you to create alert possibility for an application. This is the same steps that you will do. So it's better for you to learn it now, understand it now, like what you're doing. You can also connect to your Azure account as well. So you have Azure, you have AWS and Azure in here. I think that's it too, right? You have Azure and AWS in here. So guys, play with this, right? This is what will make you get better. Monitoring right here. This is part 2. Okay. Let me go back and give you guys documentation. You're SRE engineers, okay? You're not DevOps guys. So you're not going to do DevOps stuff. You're not going to do Python development and all that stuff. No, not really. It's optional, eh? I'm just giving it's optional. Because this is what Isabel was talking about that I sent you guys. I sent you guys this document. Python for DevOps. So you can forget about the dev and just learn the ops part of it. But it's optional. It's very easy, eh? You just copy this code and you run it on your machine. That's all. You don't have to do anything. API request. Copy this code, run it in your machine. That's all. Done. Like this. See this part? Copy, come here. You just run it. Python env.py. That's it, done. This one is read.py. It's going to read these files. We're going to read this file here. So I'm just coming and just write and read.py. Python read.py. Just read those files. This name is in this file here. And that's it. You just go to the next one, run it. So login, this is to collect logs. Import logs, run this log, that's it. So this one you might have to do. It's on your SRE. Again, like I said, it's optional, right? Databases. You monitor databases, right? You do this one. What other thing do you do as a SRE? You monitor system resources. Instead of running the command, top command on your Linux instance manually every time, you create a small Python script. You use the PSU2 to monitor system resources. So instead of you log into the instance and running the resources yourself, you just run this Python script. You just run the Python script, monitor.py, and it goes and run a command for you on that server and brings you the results. That's all. Small things like that. HTTP requests. This is the code. You don't have to learn how to code. You don't have to know how to code because the code already exists. The world has really changed, guys. ChatGPT can write code and give you now. You use it and you do your job. You don't have to learn how to code. Please mention it in an interview. The world has advanced. ChatGPT can give, you can tell ChatGPT, give me a Python code to automate monitoring of my ECG instance, and it will give you a perfect code to do that. So you don't have to know how to code. You guys heard about ChatGPT? Does everybody know ChatGPT? Huh?
Yes.
Hmm? People don't know what ChatGPT is? Kobe knows what ChatGPT is. He uses it every day. Talk about Kobe.
Yeah, that's true.
Yeah, ChatGPT has everything, guys. You don't need to struggle. Isabel, if you're trying to copy a file from one direction to another, you don't know, come to ChatGPT and ChatGPT, tell me how to copy a file from a Linux directory to another Linux directory. ChatGPT will tell you. That's it. And give you an example even. Look at that. Guys, life has become very easy. Oh, look at my initials. When I was sports betting, I used to like use ChatGPT to like ask who's gonna win the game. Crazy, man. But yeah, stop that stuff. But yeah, ChatGPT is there for you guys. Use it. Matter of fact, if you know how to use ChatGPT, your chance of getting a job are actually higher. That's the new world where we're in. Is everything is AI. So you better jump on board with this AI stuff and know how to use it. So that's that, right? There are many things in there. Look at the one that you like. Oh, look at that. Sending emails using SMTP libraries. Okay, that's a good one. You can come here and you just copy the same code and you put your email address in here from to, and you just create a file called email.py and you run the file. That's it, done. Create virtual environment, integrating CI/CD tools, database migration, testing code. Oh, for testers who want to run the testing in the testing account, right? This is the code that I'll put in the testing account and I run the tests. And when it passes, they push it back to GitHub for storage. So that's just some very basic. There's many codes in here. Monitoring application logs. Look at that. This is for you. Like I said, it's optional, right? When you go to the company, they already have these things. They already have these logs, guys. Trust me. You're walking into an environment where it's already been built. It's already been built. You're just coming here, it's done. So you're just coming here for support, keep the lights on, or it's already been done. We already did it. Okay. Yeah. Container health checks, all these things. There are many of them, right? But if you want to be a DevOps engineer, there you go. If you want to be an ops guy, you don't even have to use it. Monitoring with Sentry. We have Sentry here in our notes here. We have Microsoft Sentry. Where is it? Somewhere here. Microsoft Sentry is in these notes here. Microsoft Sentry is somewhere here. Where is it? Come on. Yeah, I think that's it. Microsoft Sentry. So I've given you guys one tool. If you guys want another one, if you want to be fast, if you want to walk alone, you guys, if you feel like walking alone makes you go fast, go ahead and go alone. In life, You go fast when you go alone, but you go far when you go together. Some of you are super people. Some of you need people to drag you on. Okay. All right, guys. So that's just Splunk. Another one is Datadog. Datadog, quick starts, AWS. And you're gonna get challenges. Don't feel like you're not gonna get challenges. It's okay to get challenges, guys. Guess what? In your interview, speak about the challenges. But the thing is that's important is when you speak about your challenge that you face, for example, in an interview, you say, oh, I was unable to restart Prometheus. It was working. But now you tell them what you did that helped you restart Prometheus. They want to know you're a problem solver. Don't just say I was unable to help unstart Prometheus and I just stayed there. This is step-by-step installing Datadog on AWS with dashboard setup. This is it for Datadog on AWS. Step-by-step. Step-by-step. Do this one as well. I like this one. Okay. Hey guys, tomorrow at 7 p.m., you can meet online and we have class. Tomorrow at Wednesday at 7, if you're available, meet. The Zoom is open, It's open for everybody. Please meet. Don't wait for me. If you want to meet with your classmates, meet. You have a WhatsApp group. If you want a private WhatsApp group that I'm not there, let me know. I'll create another one. I'll leave the group so you guys can talk among each other. Roslyn, create another WhatsApp group only for students. That I'm not involved in it.
Okay.
Yeah, so that you guys can, be as teammates. Okay. Yeah, create another one. Only you guys don't add me to it. Okay, so we're gonna go create Splunk. We're gonna create Datadog, and we're gonna start learning how to monitor these things. Okay. I'll create my own. You create your own. Then we'll come to class. If you struggle, then I'll show you my own. I want you guys to learn how to catch fish. Even the Prometheus assignment, I'll do it. I'll do it and I'll show you guys. Okay. But I want you guys to first of all learn, struggle, figure it out. That's the best way to learn. Trust me. If I just give you guys the answer, you're not going to learn. When I give you guys the answer after you've struggled, then you're going to learn from there. Another monitoring. So we talked about security monitoring as far as security goes. So we're talking about the verticals of monitoring, right? Security, health, application. They will ask you this in an interview. What are you monitoring? What do you monitor as a cloud SRE person? Oh, I monitor security, application health, database health, system health, and application functionality. Okay, when it comes to security, what do you monitor when it comes to security? Oh, I monitor phishing attacks, unauthorized deployments, intrusion attempts, these other things. What tool do you use to monitor? I use Splunk. Splunk checks for error codes, failed login attempts. It checks for sensitive personal information. That's security monitoring. I use Splunk. I've used Amazon Guard Duty, Intruder, SolarWinds, Nagios. You will call all these tools, but you may not have to practice all these tools. The reason I'm saying so is because these tools are very similar tools. Prometheus is a godfather. If you know Prometheus, you probably know every tool. Prometheus is the hardest of all the tools. It's the hardest of all of them. So Prometheus is like a godfather. So once you have learned Prometheus, you know all of them already. It's just a name. Okay? Prometheus is the monitoring tool. Grafana is the dashboarding tool for Prometheus. Grafana is the dashboarding tool for Prometheus. Prometheus is just a monitoring tool. Now, if you want to look at the dashboard for the things that Prometheus has monitored, you need to use Grafana. Prometheus to push its logs to Grafana. Grafana now shows you the dashboard. We haven't done it yet, we'll do it. Also, each individual cloud has its own monitoring tools. When it comes to security, Amazon Guard Duty is used in AWS. Okay. So you have system health monitoring. Structural system health monitoring, you have CPU utilization. This one we know. This one is the easy one for us. We know this one, right? CPU utilization, server ping test. like pinging a server, right? Like this, like running a ping. You can do run ping www.geico.com, geico.com -C5. That means only 5 lines. Oh, sorry, hold on. Small c, I think. 1, 2, 3, 4, 5. Done. That's it. Count 5, only 5 lines. So in your script, you're running your script, you schedule your script that runs every, I don't know, 30 seconds. It runs this ping and it sends the results. So you know that the server is up and running. Okay. That's a script that you can run. You can put this ping in the script and you schedule it to run every 30 seconds or every 1 minute it runs and send the results. That's it. Very, very simple. Go back here. So we're going to be monitoring CPU utilization, server ping test, server load average, file system usage. What's the command to check the file system usage? What is the Linux command to check file system usage?
Fredix. Oh, for FTX.
Have you ever seen a criminal cut themselves? I'm tired, though. I'm tired.
DF-H.
Yeah, right.
DF-H. DF-H.
I think it's just DF.
DF, I think.
No, that's not correct. What was the command to check free disk usage?
Predix is DF-H, actually.
DF what?
-H
DF-H
for
like
CD.
this?
Yes.
Like this?
No, space, then -H after the DF.
So how do I know which disk is being used? Is this correct?
Is it not a free dash H?
Free-H. That's memory.
Oh,
Oh, wow. Yeah. I'm surprised, man. This is an easy command. This is an interview question. Come on, guys. What's the command to check this usage? The answer is even in the question. Huh?
DU
Uh-huh.
space -SH.
No. It's DU-H. DU-H, and you can specify the volume, which is this one, /. So you see all the usage here for that particular volume. But there's a way to catch the process, Q. Let's see. This is the thing. That command is not a shift command cancel. Escape. Q. I'm gonna just close it out. But before I run that DU command, you have to specify the volume in which you want to see, right? There are more advanced commands online, like detailed. You can look this up, right? Detailed disk usage. Detailed disk usage. You can add this like DU-H here. And then it will tell you like, it can give you like a more detailed command, like this, right? Like a -1. Let's see. Another way is to do this. You can run a DU-H. And it'll show you like this. Or you can run a DU-help. So du dash help. I think it's dash help. There you go. So now you can go into that du command. This is the manual for Linux. Du dash help, and you can see what you can run. You can look at it, you can see, okay, dash H, dash help means, dash H means human readable. And then you can summarize, you can do dash S. Display only a total for each argument. You see that? Dash T, threshold. Dash L, count or links. Count size many times if you had link. You can see total bytes. So dash B. See? Dash B. So you can come on and run du dash H dash B. Or dash B, sorry. And you can see that's the number of this directory in bytes. You see that? So when you do a dash help, it brings you into this, and you can now see this is used for summarizing decisions of the set of files for directories. You can now pick now what you want to see. I want to see human readable. I want to see dash D, the max depth. You can come here and run dash H and dash D. Right. See, summary, 28 kilobytes. Everything here ends up at 28,000 kilobytes. You see that? For this dot directory, for where I'm currently at, like that. So take note of that. Those things come to the interview, guys. Okay. So this is your structural system health monitoring, your system, right? You want to run file system usage. Memory utilization is free-m, not free-h, guys. Free-m. Free-m. M is what? Free-m. M for memory. Free-h is the H is for human readable. Human readable. So it's showing you 949 megabytes. So 162 megabytes being used, 481 megabytes read. That's why it says H. H is for human readable. So you can also do a what? A free-m-h. And we give it the same thing. But I'm saying so because when you start running on a server that has many connections, you need to be able to run a free-m-h. Sometimes if the server is a big server and has a lot of gigabytes of memory, you need to run a free-g to see the gigabytes. But everything here is less than 1 gigabyte. That's why it's slow. That's why it's small, sorry. Any questions on this stuff? Okay. So we have a memory utilization, network. How do you monitor network? What command do you run to monitor network? What command do you run to check the network? Hey.
Pin command.
Huh?
Pin command.
Type it. Spell it, let me type it.
P-I-N-G.
No. I thought you guys did. No. No. Oh, no. So everything we've learned is just gone to waste? No, I taught this in class. Anybody heard of TCP dump? Remember TCP dump? Hey. TCP dump. Net start. Any of these? Did I teach this in class? Dig command, net start, TCP dump, dig, hostname, NS lookup. Did I teach this in class or no? Please tell me I'm a liar. Please, tell me I'm a liar.
Yes, you did. But TCP dump
When
now.
I say practice
Okay.
Linux commands, this is what I mean. This is what I mean, guys. Create an EC2 instance, log in, and practice these commands. They will ask you in an interview, how do you monitor the network? You will not know what to say, but that Debo has taught you guys. Show TCP and UDP ports and their connections. The commands are here. We're now doing SRE meat and potatoes, the main thing that we're going to be doing on the job. And you're seeing that you're going to be monitoring system health. How would you monitor system health? These are the commands. These are the commands. You either run the commands manually or you create a script or automation that will run the commands for you and send you an alert via email. Or you use Prometheus and Grafana and those tools and you sit and fold your arms and they come and meet you. But in the interview, they will ask you, what commands are you going to run to monitor network? You must know a couple now, like dig, like TCP dump, like netstat. Guys, I'm not just talking for no reason. When I say practice Linux commands, I know why I'm saying so. These are the things that they will ask you in the interview. They're going to assume that you know Prometheus. They're going to assume that you know Datadog. They're going to assume that you know Grafana. They're not going to ask you that. Most of the time, they're going to not ask you. They're going to ask you, but the original things that everyone is supposed to know who knows IT. If you know IT and you have 8 years of experience in your resume, you should know a du-h command. You should know a free-m command. You should know a top command. You should know an ls-ltr command. You should know how to make a directory because that's the English language of IT. They're not going to ask you what CloudWatch does. They know that you already know that. It's on your resume. But your resume doesn't really mention netstat or TCP dump. So they're going to ask you what is not on your resume. That's the new interviews nowadays. They don't ask you what's on your resume now. They ask you what's not on there. So if you don't want them to ask you about TCP dump, okay, put it in your resume, then they'll not ask you about it. Before the interview, they've read your resume. They know everything about you. Now they want to be able to read, ask you what they don't know about you. That's how it is. That's how it goes. Guys, I'm serious. So when I say practice Linux commands, so I'm worried, man. I'm really worried, man, because while we're doing the main SRE, you're seeing that you need to run a top command to check CPU, a server ping test, a file system. You don't know how to check file system. They've been doing this class for the last 2 months, 3 months. You don't know what to check in network. How do you check network for an application? It's here, it's in your notes, it's there. I gave you, it's right here, dig. Do a lookup on the domain name. Netstat is there. You have to practice it. Why are you not practicing these commands? What's going on? You're not going to get a job if you don't practice. This is the thing they're going to ask you in the interview, guys. This is your experience right here. You don't need anything else. You don't need any more notes. You don't need any more notes. You need to log into an instance and practice. That's what you need to do. And then when they ask you in an interview, you speak what you have done. You need to create an instance. You need to create Datadog. You need to do this, run these steps, create Prometheus, create configure Splunk. This is the things you speak in the interview. You don't need to read any more notes. Notes are not going to help you. I'm telling you. You need to do. You need to just do it. Copy and paste it. Do it. That's how you get a job. And then when you go to the interview, you talk about what you have done. That way, it's not strange to you because you have done it. You think like I configured Prometheus and created alerts, monitoring, because you have done it. You did it in class. Say like a project. You go and you have done Splunk. I configured Splunk AWS and I added instance behind you because you have done it. When you do things, you're not struggling in the interview because you have done it. But if you don't do anything, once the interview will come, you struggle what to say in the interview. You won't have anything to say because you haven't done anything. That's the simple truth. Anyway, Firewall, monitor firewall, commander is in the cheat sheet right there. I'm laughing there, man. Don't worry. I'll give you guys resume by after Thanksgiving. You start applying to jobs very soon. Guys, there are jobs there. Ooh, Donald Trump brought jobs there. The guy came with fire. Jobs just open up like that. As soon as the guy won, jobs have opened up there. I'm telling you, look at that. Jobs have opened up. I want to put recent jobs. This is just recently, 12 hours ago. It has opened up there because people are feeling positive. 9 days ago, people are feeling positive that this economy is going to boom. So they're going to start hiring again. This is all SRE jobs, and not even, this is all SRE. IBM, Oracle, everyone's hiring. So you get ready to start interviewing, guys. Get ready. Get ready to start interviewing. I've given you guys interview questions as well yesterday. Open the interview questions. Go through it. Let me send you guys this link to this. Let me see. Try if you can access this link, guys. Copy link notebook. View only. This is the interview link I'm keeping in the chat. Try to access it if you can. Start interviewing there, guys. It's time. It's time, eh? You're gonna answer a phone call, speak to the recruiter. It's not gonna go well. It's not gonna. First one's not gonna go well. The first 5 is not gonna go well. You don't give up. You keep going. But it's time. It's time to make money. Time to get a job. So how the monitor system help? The server performance, percentage of CPU utilization. What's the command for percentage of what's the command for CPU? What's the command for CPU?
Top comment.
Okay. What that command is there for CPU? If I were you, I just go and read it from here. Just read it from here. PS command is there. Top command is there. HTOP is there. There are many commands there. Background process, BG is there. Right? BG, background. There are no jobs running. If it was job running, you run BG and then the job name. All right. Okay. HTOP is there. Top command is there. You have what do you call this other command? PS-EF. You can grep. A PS command is there as well. Okay. Rest my case. So you monitor server performance, you monitor CPU, the load average. Load average command, to send the load average on the server, you need to run the command uptime. Uptime. You can see the load average in that server right here. Now it's empty, but you see the load average here. It's the uptime. You see how many users are connected there. You see for how long the server has been up. And then you see the time in UTC time, right? So that's load average. Percentage of memory utilization. So memory utilization is what? 3-M-H. You see that. So you can calculate used divided by this times 100. That's use. And then percentage. And then free percentage is this divided by this times 100. You can create a small script that will run this command for you and then do the calculation and then give you. It's very, very easy. It's simple mathematics, right? And you schedule it to run every 10 minutes. Or you just configure Splunk. In fact, that's what Splunk does there. Splunk runs these Linux commands on the background, in the back end on the servers for you. And guess what? Splunk is making a lot of money with these tools. Companies pay millions to Splunk to use them. But in the back end, Splunk is running these commands. Same thing with the Datadog. They're running commands in the background for you. That's all they do. That's all they do. All these tools, fancy tools, they run the commands so you're able to see You're able to see how many functions or everything like that for Lambda function, for example. You see? All these things you're going to see. Dashboard, infrastructure, monitors, metrics, integration, APM, notebooks, everything. Datadog does it for you. This is how your account will look like when you start working. This is how you will see after Datadog, like you'll be like this on dashboard. Like I said, you can either watch this dashboard manually every day, or you can sit down and create an alert and you just check your email or you get an email. So it's up to you on how involved you want to be on the job. I'm a guy that wants to just chill. So I'd rather just create the monitoring alerts to my email and just chill. And when I'm chilling watching TV at 2 p.m. in the afternoon, yes. And then when I get an email about an issue, I check it. No email, no checking, nothing. I'm watching TV or playing video games. Life is very easy. So you determine how you want your life to be, really. Server response time. Server response is a ping test. Like I said, right, you run a ping test and you're pinging the server. You do a ping-echo.com-c5, means it will run five times, 1, 2, 3, 4, 5. And you can post it, send it to a file and send the response. Or you can write a small script that says, if it successfully returns 64 bytes, then it means server is up. If it doesn't respond that, it means server is down. There are small scripts like that, right? How do you find the script? It's online. Server, ping, tests, shell script. You don't have to write anything. That's the script. That's it. Very, very simple. Check if a hostname is provided as argument. That's all. See, ping, dash this, for, if host is reachable, else reachable. That's it. Perform a ping test. That's the code for it. You copy that code, you put in your, you save it, you run your schedule. That's it. Done. Done. You don't have to write code, guys. I'm serious about what I'm saying. You don't have to know how to write code. You don't. You just need to know how to Google. That's it. And you can say it in your interview, and that's fine. But the ping test is a script that you create a script. If it doesn't really exist, I'm saying to you that when you go to the job, when you guys get to the job, most of the hard work has already been done. Most of the scripts that already exist. Most of them already exist. So you don't have to do anything. You don't have to do anything, guys. Okay. Any questions, guys? Any questions so far on any of this? So next thing was the percentage of file system used. Like I said, it's a calculation. You run a du-h command, and all these tools can calculate it for you, right? And then you have the firewall access logs. So the logs will be pulled by these tools. Splunk can pull those logs and tell you who accessed what at what time, those kind of things like that. Okay. Real-time application monitoring. This is application health, application performance metrics, application health, the response time from the application, right? Like prior time, end user experience. We're monitoring that end user experience. Time-consuming transactions. When you buy your flight online, how long is it taking for you to get your confirmation code? Cross-application tracing, health, the port URL monitoring, monitoring all incoming connections from port 443. Right? Garbage collection, this is for Java applications, something called garbage collection monitoring. When memory spills to disk, we'll talk more about that. We'll monitor that as well. But this is more application monitoring. You may not be involved in this too much because it has to do with code, like the Java. But these are the tools that I use to monitor the application. All these tools, Azure Monitor, CloudWatch, Grafana, Dynatrace, App Dynamics. The most important one for this, among all these tools for this application monitoring, is App Dynamics. Because app means application, right? So App Dynamics, Quick Start on AWS. This is it. AWS monitoring, App Dynamics. It's free trial, and boom, we'll run through it, right? for software as a service applications, right? So that's that for application health. For application functionality, you look at the metrics of application monitoring, application flow, API response time. This is the business logic, the error code. This is mostly for application developers. API response time, failure rate, anomaly detection. Again, Dynatrace or App Dynamics can do that application monitoring for you. You won't be involved too much of this, but again, it's just good to know. Then database is the one that you'll be involved very heavily, very, very heavily. You'll be involved in databases. Critical database monitoring elements, replication lag, right? What's replication lag? When we're doing replication from one database to another, right? That's a lag can occur. A lag can occur. Let me explain what that means, replication lag. So we saw that in our 3-tier application. Let me open it up. I think I have documents right here, this one. Do you guys have all these diagrams on documents? This one? You have this one as well? No? Okay, I'll send to you guys. So we know how requests is sent from the client down to the web servers, down to the load balancers, right? The load balancers spread the load across multiple servers down here. And then this application layer is a business layer. This is where your request is actually processed. Let's say you're buying something online on Amazon.com. It's processed here and then it's saved in the database. When your information is stored in the database, the order ID number, the other things like other, the logs, the data that is saved here is also replicated to another database called standby database. So that if this one goes down, this one will continue supporting the application. That's what we call high availability. High availability means that we must have another database or systems that are highly available so that if one database goes down, this other one will continue to receive application requests to process client requests, right? So when information is stored in the database, the information stored here has to be replicated over to the standby database. That time it takes for the data to go from here to here, if it falls above 5 minutes, let's say this database here is currently at 8:53 p.m. But this database has data only as of 8:50 p.m. This database is 3 minutes behind this database. So when we're doing monitoring, we're able to see in our monitoring tools, like in Oracle Enterprise Manager or Splunk or CloudWatch, we're able to see replication lag. Replication lag means that the target database is behind the primary because it's supposed to copy data from here to here in real time. And this is supposed to be in sync with this guy. It's supposed to be in sync. That's supposed to be in sync. Means that if this guy has 400 tables, this guy should have 400 tables. If this guy has 200 records, this one supposed to have 200 records. But there are times then, because of the network slowness, this standby database is behind. So what is our acceptable time frame? If it's under 5 minutes, it's fine. If this database is more than 5 minutes behind its primary database, then it's an issue. So we need to log in and maybe do something to the network, check the network, maybe stop everything here so that this guy can catch up before resume it, right? So that's something that you monitor a lot. You need to also take note of, you need to know what database is it. Is it a SQL Server database? Is it an Oracle database? Those kind of things. Okay. Any questions on replication lag? So the replication lag is just in between that this standby database is behind the primary database. That's all it is. Any questions on that? Then we're also going to monitor open connections, monitor IOPS. IOPS stands for input output per second. Please write this down. Please write it down. IOPS stands for input output per second. Input output per second. Input output per second. We're also going to monitor expensive queries. That means that requests that are taking a long time to complete, they're called expensive queries. Then we're going to look into throughput. So we want high network throughput. We're going to look into disk space usage. Again, DU-H, DU-F, whatever one you want to use. Change all of that, and then the errors are on the database. So how do we monitor performance? We look at database verification log, number of open connections, we look at the IOPS. This is all in your dashboard. Like I said, there's 3 ways. Either it's in your dashboard, either you create alerts for them. If they go high, send you an email. You don't care about it. You don't want to look at it on the dashboard. Just sit down, create a threshold. If applications are above 5 minutes, send me an email. If it's under 5 minutes, don't send me an email. I don't want to know about it. If the expensive query is above running for more than 5 minutes, send me an email. I'll log in and I'll check. If not, don't send me an email. So you have that ability to create an alert for all these things that I'm discussing. Or you can just watch the dashboard. The best method is to get alerts, because looking at it with your naked eye, you can miss something. Human beings are bound to make errors because we can miss something. You can see yellow because you're tired, you see guys green. So create alerts is the best practice. And also it gives you some time to chill as well. If you don't have alerts, you can chill. You can be on lunch break and your phone rings, alert, and you have time to finish your lunch and go work the issue, right? Long-running database queries, we'll monitor that. So if long-running database query, I mean, if the query is running for more than 10 minutes, it's an issue. Or it can depend on the business. Companies like Geico that produce ID cards, insurance ID cards, if it's taking more than 5 minutes, it's an issue. But anything less than 2 minutes is fine, because to create your ID cards, you need to use your driving record, everything. So it needs to generate an ID card. So it takes a while. So that's how you look at it. It depends on the company. 10 minutes for some, it'll be okay for some companies. 20 minutes okay for some companies. So long-running queries, if it's above 30 minutes, in my company where I work, anything above 30 minutes is an issue. We have some huge queries that create reports. We have to go that create reports at 4 p.m. every day. It collects all the stock transactions for the New York Stock Exchange in New York. For that whole day, it creates a report of what moved the market, what made the market grow into green, and what made the market move down. And then we publish that report into the customer's accounts. I work for a life insurance company, by the way. So in the customer's life insurance, the customer's life insurance accounts will show them what moved the market up that day and what moved the market down. So we collect all the stocks, that transactions that day that had a volume of more than 100,000 volume. That means buy and sell. We compute it in Redshift, in AWS Redshift, compute it, and then create a huge report. And that report is now pushed now to customers' personal accounts, so those can see in the mobile app. It takes more than 30 minutes to run, and that's okay, because different days have different volumes of data. But if it takes more than 2 hours to run, we're going to get an alert that the report query is taking forever to run. So customers will get that report before 6 p.m. every single day they get it, Monday to Friday. So the long-running query for us is if it's above 30 minutes, it's fine, but no more than 2 hours. That was the time frame. So anything above 2 hours, you're going to get an email. If we don't respond to the email within 10 minutes, you're going to get a phone call. If you don't answer the phone call 3 times, the phone call goes to your manager. Your manager picks up that phone call and call you, you're in trouble. So database throughput, we'll monitor that as well. Database storage, which is DF-H, right? DF-DU-H. Then the health connection, database connection errors. Look at the number of errors I'll call. If we're seeing too many errors, then it's a problem, right? We shouldn't be seeing too many errors. And then look at the database VM monitoring as well. So that's it. Alerts, real-time alerts is good for us. Being proactive, look at the growth rate, response time, memory leakage, look at those things. Proactiveness is good. may or may not have impacts, potential risk. Being proactive is that we look at once in a while, we'll look at the dashboard and we'll say, hey, that server is growing. That server is currently at 80% usage. Can we add more space to it? Let's add more disks to it before it reaches 100%. That's you being proactive. Or it can be like me, that I've seen a disk at 80%, I just sat quiet, I didn't do anything. Until it hit 95% and it was started complaining, warning. That's why I went and acted. Or you can be a good person. At 80%, you send an email, hey guys, server number 005 is approaching 80% disk. I think we should add the space because it's growing, that space is growing very, very fast. It's okay, set up a meeting, let's talk about it. Set up a meeting, you guys discuss it, you do the planning, and then you schedule the day that you're going to make the change. On that day, you log in, add more disks, configure it, or you open up a ticket, let the DevOps guy do it. That's how you're smart. You don't do it. You complain about it, and I'm inside of a meeting. You guys do the capacity planning about it, and then you open up a ticket, and then the DevOps person implements it. That's what I do. Unless it's an emergency when it's bad, it's 99%, then you can go and do it. But if it's at 80%, open up a ticket, let the DevOps guy do it. They're the ones who create things. We only monitor and report. That's our job. Like I said, reactive is when you are reacting. Damage is caused already. Yeah, you're reacting. But to be honest with you, most of us react, guys, right? The best employees who get promoted are the ones who are proactive. I'll be honest with you, right? I'm not gonna sit here and say I'm proactive. I'm not, right? I work multiple gigs. I don't have time being proactive, honest with you. You know, it's all about making money and moving on, living life. I'm not trying to get promoted, honestly. Powerful alert management. So alert management is very important. Step-by-step action plan, right? Store your alert at a common location that all the team can access it. So that if you're on vacation in Hawaii and there's an alert, the other teammates can go and access it, right? Don't send the alert only to your email. And then, there's something called a group distribution list. So you belong to like cloud, SRE, ad, Geico.com. In that distribution list, there's like 16 of you in there. When the email comes, everyone will see the email. If you're not around, someone else will go and look at it. All right. And then whom to notify when alert triggers. Whom to notify. The whole group doesn't want to be only you alone, right? What to notify, error codes. You need to have critical level, high, medium, and low. So we only want to look at high and critical alerts. Medium alerts, we don't really want to look at them. Low alerts, we don't really care. So we can say for low and medium alerts, don't send us an email. For high and critical, send an email. Number of events in a time interval. How many events should we send to you configure within 1 hour? You need to discuss that things. Some companies have a rule, like the ping test is every 5 minutes or every 10 minutes. So you have to discuss those intervals. The rate of occurrence, discuss that stuff, right? Frequency, alert represents standard operating procedures, the alert parameter, the alert severity. Severity is very important. Critical or high is what we want to look at. Whenever you see high, take a look. If it's not that important, then leave it. But when it's critical, everybody is going to come on the call. Escalation. Severe, the manager is there asking you how many minutes do you resolve it, putting you pressure. Okay, so sometimes it's good to be proactive so you avoid this reactiveness. Any questions, guys? We are above time, right? So tomorrow, Wednesday, we'll continue with SRE fundamentals, SLO, SLI, and error budgets. We'll talk about this stuff. We'll go more detail into it. If you guys want to have class tomorrow, let me know. I'm available for class tomorrow and Wednesday. Okay.